Yes, Satyam, you can
Okay.
start.
Okay. Okay. Hello, everyone. My name is Satyam, and I'm a third year student at Indian Institute of Information Technology, Sri City. I welcome you all to the PYQ series of SATHEE, where we'll be discussing questions from the previous years in JEE Mains. Our pehla chapter, which we are going to discuss, is physical world and units and dimensions. So, guys, one thing to understand here is that physical world, units and measurement basically is one of the fundamentals chapters of your JEE, and you will be having this fundamental chapter everywhere. Okay, so make sure you know have a strong base upon it. And second thing is that you have very less questions in JEE Mains, but this is a very scoring chapter. Okay, so make sure that your fundamentals are clear with this chapter. And yes, let's move further with this. So we have our first question. Okay, so this is basically the dimensions of universal gravitational constant. Okay, so what are the dimension of universal gravitation constant? Now, to look at the solution over here, let's check. Now, you know that what is universal gravitational constant, right? So this is the formula of basically gravitational force, right? This is the gravitational force between two objects. Okay, let's say that this object is mass m1, this object is mass m2. They are separated by a distance r. Then what is the gravitational pull between them? F vector. This is g m1 m2 by r square, right? This is the formula of the force. So now what I have to do is I have to calculate the dimension of g. Now this is in general for whatever quantities you are going to measure. Okay, let's say that if you are comparing at the electrons level, then you have Coulomb force, right? K q1 q2 by r square. So this is the constant. Now what I'm going to do is I'm basically going to see the trick over here is that whose unit you have to calculate, you have to keep it at other side, and rest all units you have to keep it at other side. Okay, so this is the formula. After rearranging the formula, what I'm getting, g is equals to f r square divided by m1 into m2, right? Correct. Now you should be aware of basic dimensional formulas of every units, right? So now I have got my final formula. Okay, for g, right? I've got this formula for g, correct? Now what I have to do is I have to basically find the dimension. What will be the dimension? So dimension of this will be, I have to basically evaluate this dimension. So force dimension, you everyone know, mlt minus 2, right? Then L square is for r square, as r square is nothing but length, right? R is basically the distance. Distance की सबसे fundamental quantity is length. Okay. For mass, you have m1 and m2, right? So this is mlt minus 2. Okay. Then you have L square, and this is divided by m and another m, right? So when you further manipulate this, m and m will get cancelled. You have one m, just bring it upside. So this is m minus 1. Okay. You have one L and L square. That becomes L cube. And then you have t to the power minus 2. So this is the dimensional formula for gravitational constant g. Okay. So this was one of the PYQs. This is one of the very easiest questions. So please make sure that you do this correctly. Okay. Calculating the dimensional formula of any quantity. This is one of the fundamental questions I'm telling you again and again. So what you have to do is you have to basically bring one quantity another side. Let's say the quantity is g, as you needed to calculate its dimensional formula, and all other quantities at the other side. And for each quantity, you have to derive the dimensional formula. Like for force, okay, force. Then you have force. Then you have your radius. Then you have m1 and m2, right? Okay. So I hope this is clear, right? Uh, let's move to the next question. Yeah. So yes. So which among the following groups have quantities that do not have the same dimensional formula, right? Just a second. Yeah, same dimensions. So coming to this question, solution is that force has dimension of mlt minus 2, where impulse has mlt power minus 1. Okay, both have different dimensions. Again, the formula is same. Okay, pressure is force upon area, right? And then you have velocity, which is meter per second square. Okay, right? Speed is also meter per second square. So do not have the same dimension, right? Do not have the same dimension. Like, let's say that I'm taking one example over here. Let me take this option B. Okay, the option B example, let me take. So velocity is measured in meter per second square, right? As well as speed, meter per second square. Correct? So meter per second square. Meter, what is the dimensionality of meter? That is length. So length divided by seconds. Seconds is measured in dimensional quantity. What is the fundamental quantity? It is time, right? So this is time square. Now you just bring this up. This is LT power minus 2. The same quantity is for velocity. The same thing is for speed, right? Same thing is for speed and same thing is for velocity. So no worries, right? Okay. Similarly, pressure and stress. Okay. Then you have force. Work and energy also are same, right? It's just that the force and impulse have different dimensionality formula, and this is what they have been told over here, right? Okay. Yeah. So let's go to the next question. Okay. I hope you understood this. Simple derivations, nothing else. Okay. The unit of thermal conductivity. What is the unit of thermal conductivity? So for calculating the unit of thermal conductivity, it is important that you know its formula. So this is a formula, okay? In steady state, okay? The amount of heat flowing to one phase of the other time dt, okay? So this is the formula, okay? Now what I'm going to do, I'm basically going to derive this, right? So as they said, H is equals to Ka into T1 minus T2 dt divided by L. So this becomes dH by dt, okay, with respect to time. This is Ka by L is your constant, right? Then you have T1 minus T2, that is delta T. Fine. So now what they have asked you? They have asked you thermal conductivity, which is K. Again, for K, what you have to do is you have to again rearrange. So K ko ek side la do, and then L dH divided by A into dt into delta T. A into dt into delta T. This is what now you have to break down. Okay. So when you break down, you will get this formula. Okay. Dimensionality formula. Okay. In simple terms, you just need to, they can even ask you about what is the dimensional formula. This is what the unit is. They can even ask you dimensional formula. So please be sure of that thing. Okay. Also, guys, one thing what you have to note is that units and measurements is not a different chapter all over the other. Okay. It's just that they can give you any chapter mixed with units and dimensions. Okay, they can bring magnetism, they can bring your modern physics and everything. Okay, whatever you can have any simple formula, and that simple formula they can tell you to calculate the dimensionality constant of a particular constant. As simple as that. Okay, so this chapter units and measurement can be mixed with any other chapter. Like, okay, so please make sure that at least you are clear with the formulas of each and every chapter. Okay, that is what required in JEE Mains. Fine. Moving to the next question. So if dimensions of critical velocity Vc of a fluid flowing through a tube is expressed as Hx, Py and Rz, where H, P and R are coefficients of viscosity, okay, viscosity of fluid, this is density of liquid, and radius of the tube respectively, then the values of X, Y, Z are given by. So this is the solution, okay. So we will be basically applying dimensionality method, okay. Here, now we know that Vc is equals to, we will be deriving it in this form, okay. Dimensionality method, Vc is equals to neta to the power x rho to the power of yr into z, okay. This is the dimensionality formula of critical velocity. Fine. Now we know that coefficient of viscosity is neta, which is f upon 6 pi rv, right? That's what you have to replace it over here. Now again, f, dimensionality formula of f is ml t power minus 2, correct? Okay, then you have pi r square, right? So pi r v, okay, this is pi r v, okay, v. So pi r is length, that is 1l, and v is lt minus 1, correct? Lt minus 1, okay. So this is viscosity, okay. Similarly, you have density, okay. Density is m per L cube, right? You have radius. Fine. I hope this part is clear. Fine. Now you have to put these values in this fashion. Okay. Because let's say VC is equals to neta to the power X into rho to the power YR into Z, right? Into R to the power Z. R to the power Z. Okay. This viscosity term is related to neta, rho, and R. That's why I have multiplied them and I have kept powers. So basically, I want to calculate these powers. To calculate these powers, I will be basically deriving the dimensionality formula. Okay, that is what we have done over here. For each and every quantity, I have derived the dimensionality formula, then X, Y, and Z. So now this is basically a trial and error method which you have done over here. And through this, you have got X equal to 1, then Y equal to -1, and Z equal to -1. Okay. So X equal to 1, Y equal to -1, and Z equals to -1. This is what they are saying over here. Okay. Again, see, there's nothing to be a detailed explanation over here because the viscosity, neta, you should know the formula of neta, right? F upon 6 pi RV. You should know the formula of density. You should know the formula of radius. Everything is given in front of you. It's just that you need to convert that formula into a dimensionality formula. Okay. Correct? Fine. Let's move further. Okay. Yeah. If force, velocity, and time are taken as fundamental units, then what is the dimension of mass? Okay. What is the dimension of mass? So, force and everything are fundamental units, right? पहले हमारी fundamental units, what are the fundamental units? ML and T, we used to take ML and T, right? Correct? Now what they have told us is, if force and velocity and acceleration and everything are our fundamental quantities, how will you derive the dimensionality formula of mass? So we know that force is equals to mass into acceleration. Correct? Okay. So mass is equals to force by acceleration. Correct? We know what is force, right? So force divided by, okay, so mass. What is acceleration? Acceleration is nothing but velocity by time. Correct? Now what they have told us that force is a fundamental quantity. Okay. Force is a fundamental quantity. Velocity is a fundamental quantity. Okay. Time we have a fundamental quantity. Then what is mass? So that is F. I will not derive F because it is a fundamental quantity divided by velocity. Okay. Divided by time. So time inverse, it goes up. If this is time inverse, then if it goes up, it is time positive. So F, V is on numerator over here. Okay. So V minus 1 and T. This is the formula. Understand one thing, what they have told us. Let's come back to the question again. Okay. Let's come back to the question again. What they have told us. They have told us that force, velocity, and time are taken as fundamental units. See, fundamental units are the units which cannot be derived further. Okay, so I have to just leave F as F, velocity as V, and time as T. Okay, please note of that thing. Then the dimension of mass are. So you have to basically derive a formula, get a formula where you can see force, velocity, and time together to get mass. Okay, I hope this point is clear. Okay, yeah. If you want, I can explain it again. So yeah, here itself. So what we have done is, I have seen force, I have seen velocity, I have seen time. So over here, I thought that there is a relation between velocity, that velocity by time is nothing but acceleration. And now I have force and acceleration, and I need to get mass. So best formula is force is equals to mass into acceleration. Correct? Over here, mass is equals to force by acceleration, which is force upon velocity by time. And now F V minus 1 T. That's all. I hope this is clear. F V minus 1 and T. Option D. Okay. So mostly the things should be clear over here, right? Yeah. So this is what I have explained. Cool. Let's move further. The pair of quantities having the same dimension. Again, this is very easy question. You should just check the same dimension. Okay. Just derive for everything. Okay. again, now they have said that same dimension. Okay, same dimension. Just pick up an option. If you get it correct, it's fine because it's NEET question. ये NEET का question है, तो I'm assuming that it is a single correct answer. Okay, you have got the single correct answer, then move further. No issues. Okay, yeah. Dimensions of m naught e naught to the power minus 1 by 2. Okay, okay. So what is m naught e naught? This is permeability of free space, right? Okay. Permittivity of free space. Okay. And mu naught is permeability of free space. Okay. It is noted over here. It is, as you can see, it is noted over here, but I'm just telling it for your convenience. Okay. So this is power minus 1 by 2. Okay. You should know this formula, that C is equals to 1 by under root of mu naught into epsilon naught. Correct. Just note this thing. And yeah, you're through. You'll get LT power minus 1. Why? Because speed is meter per second. Right? Meter per second, 10 to the power 8 meter per second, right? Speed of light. You have meter per second, that is LT minus 1. Simple. Okay. Let's move further. Okay. Now, the dimension of 1 by 2 eta naught, where eta naught, E naught is of permittivity of free space and E is electric field. Magnetic electrostats question. Okay. So you can see that this is what I have to derive. So L cube is down and this is up. Okay. Again, you have to basically derive electric field and you have to derive epsilon naught individually. Okay. These both are the quantities which you have to derive. Okay. Represent energy density, right? Energy density, that is energy per unit volume. Okay. Okay. We are cool. Let's go to the next question. If dimensions of a physical quantity are given by M, A, L, B, T, C, then physical quantities will be. Okay. Now, this is what they have given. So, okay. Okay. This is simple, right? This is simple. I feel that this is simple question. Okay. Let's say that velocity. Velocity is meter per second square. Okay. So, meter second power minus 1. That is m1l0 t power minus 2. This is for velocity. Let's move further. Acceleration. What is acceleration? It is velocity by time. Okay. Velocity by time. What is velocity? Meter per second square. Okay. So by t, meter per second. Okay. So this is m l minus 2 t0. Correct. Correct. T0. Yeah. Just a second. This is not T0. 1 second, 1 second, 1 second. Velocity by time, right? You can have a look over here. Yeah. Okay, the correct answer over here is pressure, because they have mentioned that the dimension of a physical quantity are given by this, then the physical quantity will be. Okay. Like this is the correct option, basically. Okay. Which of the following, this is the next question, which of the following 5 physical parameters have the same dimension? Again, very repetitive question. Okay, very repetitive question. You see Young's modulus, magnetic field, dielectric constant, refractive index, energy density, whatever the term is given in the entire physics. Okay, that's what they can ask. Now you have to individually derive it. Okay, you have energy density, which is energy by volume. Okay, volume L cube. Okay, and what is energy? ml2 t power minus 2. Here, this is again derived over here. Refractive index and dielectric constant have no dimensions, right? Because they are constants. Coming to Young's modulus, force upon area into L by L naught, delta L. Okay, and this is the final dimension. This is the final dimension. Okay, let's move further. Dimension of resistance in an electric circuit in terms of dimension M, L, and T and I would be. There you go. So what is resistance? What is resistance? एक law आपको याद होगा. You should remember that. Okay. V is equals to IR, right? This is the law. They have told resistance. This is V upon I. This is Q into I. That is W divided by I into T into I. Work per charge, right, is V. Voltage, correct? So W upon this, okay? So ml2 minus 3 I minus 1 divided by T into I, which is ml2 T minus 3 and I minus 2. This is what given over here. Okay, fine. Okay, chalo. Let's move to the next question. Uh, yeah. Okay. The velocity of a particle at time t is given by v is equals to at plus b upon t plus c, where a and b are constant. Fine. The dimension of a and b and c are respectively. Okay. Just look at this. So dimension is a into t. Okay. Acceleration into time. So a is lt minus 2. You can have a go through of this question. Okay. You basically need to focus on this equation. Okay. This is the equation you need to focus on. Okay. A, B, and C are constant. Then the dimension of A, B, and C are respectively. So first derive for A, then derive for B, and then derive for C. Okay. Yeah, that is what they have done over here. Okay. The ratio of dimension of Planck's constant. Okay. What is Planck's constant? Planck's constant was H, right? Planck's constant was H. Moment of inertia, that is I, right? Capital I, as I remember. Okay. So is this dimension of which quantity? So dimensional formula of Planck's constant is this. Okay. And dimensional formula of moment of inertia I is ml square. You have to calculate the ratio. Okay. As you need to calculate the ratio, this m and this m will get cancelled. L square get cancelled. You have t minus 1, which is h upon I is t minus 1. This is the dimension of frequency because f is equals to 1 by t. That's correct. And in options also you have frequency, right? Right? Frequency. So time is t, frequency is 1 upon t. So 1 upon t is t inverse, and that is what they have mentioned over here. All right. Yeah. So frequency. Now let's go to the next question. The density material in CGS system of unit is this one. Okay. Length is 10 centimeter. Unit of mass is 10 grams. The value of density of the material will be. Okay. CGS system. So what they have told that CGS system, this is the value, what they have given. Okay. Unit of length is 1 centimeter. Mass is 1 gram. Okay. In others, you have to basically derive it. Okay. Derive this. So as it is 1 gram. Okay. So density 4 into G. G value you have written in terms of mass. Okay. And this is in length, standard length. Okay. Standard length. Fine. So what you have done over here is that density is given to me as 4 into G upon centimeter cube, right? So what I'm basically going to do is I'm just basically multiplying it by 100 grams by 100. Okay. 100 by 100 grams. And I'm writing this by 10 by 10 centimeter cube. Okay. So this is 4 by 100. And this is 1 by 10 whole cube into 100 gram divided by 10 centimeter whole cube. Correct. This is 4 by 100 into 10 cube into 100 gram divided by 100 centimeter cube. So quantity which you have to write over here is 40. Okay. I hope it's clear. Okay. See, again, same formula. Planck's constant, formula yaad rakho. E is equals to h nu. Okay. Right. E is equals to energy का formula h nu. So h is equals to energy by v nu. So ml2 t minus 2 nu is t minus 1. So this is ml2 t minus 1. Right. This is the formula. And angular momentum is I into omega. inertia that is ml square hota hai, and your omega is t minus 1. Omega is measured in frequency, so ml2 t minus 1, even this thing, both are same. So the dimensionality formula of Planck's constant h and angular momentum, this the same. Okay, angular momentum is L, represented by L, capital L, sorry. Okay, fine. Okay, chalo, let's go to the next question. The dimensional formula of magnetic flux, again, magnetic flux is dimension of magnetic field into dimension of area, correct? What is magnetic flux? Magnetic flux is basically magnetic field into dimensionality of area, your area. Okay, this is the dimensionality formula of magnetic field, and this is the dimensionality for area. Okay, and this is your answer. That's all. Okay, now the force F on a sphere of radius A is moving in a medium with velocity v. Okay, it's moving with a velocity v. This is given by F into 6 pi h av. Then what is the dimension of h? Okay, so sphere, this is the formula. F is equals to 6 pi neta av. You have to basically calculate the value of neta. So neta will be F upon 6 pi av. Okay, force dimension formula, 6 pi are constants. Okay, you have x, you have a, that is L. Okay, you have v, that is lt minus 1. Cool. Okay, so this is it. I hope it's clear. Moving further, so see what they have given is, equation is given by this. Okay, P is pressure, V is volume, this is theta, theta is absolute temperature, the value of A and B. Okay, so what A and B are constants, then A will be. So you have to basically apply principle of homogeneity. Okay, so this is the concept. Yeah, this is the formula what they have given to us. Okay, according to principle of homogeneity, with the same dimensions can be added or subtracted. Okay, if you have same dimension, you can add it or subtract it. Just say you have 2 meters. If I tell you I have walked 4 more meters, so what are you going to do? Total, I'm going to add this, right? How I'm basically going to add? I'm basically going to add because both are same dimensions, correct? I cannot add 2 meters plus 2 liters, right? This is senseless because they don't have, no dimension is same, no same dimension. Okay, so principle of homogeneity basically tells that the quantity with same dimensions can be added or subtracted. Hence, dimension of P, okay, pressure, is A upon V square. Dimension of force, that is dimension of force upon area, that is A upon V square. Okay, now you're going to basically just add it, correct? I hope it's clear. Okay, यहाँ पे एक ही बात याद रखने की जरूरत थी, what is principle of homogeneity. Okay, so this basically principle of homogeneity tells that same dimension quantities can be added or subtracted. Okay, right. Moving further, which of the following will have dimension of time? LC, R upon L, L upon R, या फिर C upon R. Okay, so among these options, you will basically have iota R, then IR is equals to minus L. So RL circuit. Okay, okay, so in RL circuit, so that is L by R. Fine, you have to, this chapter, to the ones who don't know this chapter, make sure that this chapter is electromagnetic induction. You have to have a knowledge about electromagnetic induction and capacitors. Okay, because RC circuit also is given, right? RC circuit, LR circuit, these all circuits. Okay, make sure you revise this chapter. So you have to know this formula. Once you know this formula, you know, deriving the dimensional equation is easy. Fine. Which of the following is a dimensional constant? Okay. So out of these, a quantity which has, option is D, a quantity which has dimension and constant value is called dimensional constant. Therefore, gravitational constant is this. Okay. Basically, what is the dimensional constant? Dimensional constant is a constant which is a constant and it has dimensional formula also. तो वो हमारा gravitational constant है. Okay, what is the formula of what is the value of gravitational constant? 6.67 into 10 to the power minus 7 meters meter square per kg per second square. Okay. Some people don't remember the formula of this. Okay. So G is equals to 6.67 into 10 to the power minus 11. Okay. Meter square per kg per second square. Right. Some people don't remember this. For them, okay. For them, you everyone know that this gravitation constant G comes from gravitation chapter. Count the number of gravitation, count the number of letters in the gravitation. Those are 11. So just remember that it's 10 to the power minus 11. It's a very simple trick which I discovered when I used to study. Okay. So you can also apply this thing. Okay. Fine. If anyone is forgetting the dimensional formula of, uh, I mean, the value of, okay. If anyone is forgetting the value of gravitational constant G. Fine. So we'll move further. Okay. The time dependence of a physical quantity P. Okay. Uh, time dependence of a physical quantity P is given by P is equals to P naught into E की power. Okay. EXP, बच्चों. EXP. Okay. EXP is nothing but, just a second. Yeah. So P is equals to P naught E to the power minus AT square. This is written like this. Okay. Sometimes EXP will be written. Don't get confused. Okay. Fine. So they are saying you to calculate the constant A. Okay. Now I think it will be clear. This is this. Okay. Fine. Alpha is equals to 1 upon T square. That is 1 upon time dimension square. So T to the power minus 2 is a dimensional formula. Fine. Okay. So I want you all to read this question once. Okay. Uh, turpentine oil is flowing through a tube, okay, of length L, okay, and radius R, right? So there's a turpentine oil. We have a pipe basically of length L and radius R, okay, R, capital R, fine. The pressure difference between the two ends, okay, like this is P, P1 and P2. So P1 minus P2 is P. So H, viscosity H is given by P into R square minus X square divided by 4VL. This is given, okay, where V is the velocity, X the oil at a distance X from the axis of the tube, okay, then the dimensions of H. ठीक है, ये इतनी कहानी बता दी है. You basically need to calculate this, okay, using this formula. Nothing. Viscosity formula, you know, okay, P into R square minus X square divided by 4L, okay. I hope this is clear. Okay. See, they will make stories. See, the questioner will obviously make you stories, but you just don't have to get trapped in that story. Okay. Try to analyze. Okay. They are given this. Okay. You just need to focus on this formula. You have to derive the dimension of H. Now, this is distance. This is R is a distance. You just need to derive the dimensionality formula of pressure. And at the end, you need to derive the dimensionality formula of velocity as well as length, which is very simple. Nothing else. Okay. To be honest, nothing is given. This is pressure. This is radius. Radius is basically your distance. X is your distance, which is again L. Velocity is meter per second square. M upon T square. And this is L, which is again your length. Okay. So I hope this is clear. Fine. Chalo. Okay. T represents the radius pressure, C represents the speed of light, and S represents the radiation energy striking unit per area. Okay. The non-zero integers x, y, z such that this is okay. Again, just go through this once. Just a second. Yeah. So expression alpha is given. Okay. Expression alpha is given over here, right? Now dimensionality formula of alpha is given this. Okay. So pressure का तुम्हें पता है, pressure is equals to force upon area. Dimensionality formula of force is ml t minus 2. Okay. And area is L square. Fine. You have got this. Now what they have told is, yeah, radiation energy. So radiation energy is S is equals to energy plus area into time. Okay. Again, one dimensionality formula of energy. Energy का dimensionality formula क्या है बच्चों? M L square T minus 2. You have L square, which is your area. Okay. And then you have your time. Time is T itself. Okay. Now you have to basically equate these two equations. Okay. Equate as in you have to compare. You have to compare. So you will get three equations. X plus y is equals to 0, minus x plus z is equals to 0, minus 2x minus 3y minus z is equals to 0. Three equations, three variables, easy to solve. So x equals to y, x equals to 1, y equals to minus 1, and z equals to 1. Okay. I hope it's clear. Fine. Chalo. So I hope you understand this question. Okay. Yeah. Just a second. Yep. Again, same question, 1991 JEE or NEET. The dimensional formula for permeability M. This is the formula. Okay. Just a second. Yeah. So permeability of free space, that is mu naught 2 pi into force into distance upon current square into length. You have to derive each and every dimensional formula for each and every quantity. Okay. Just like force, distance, current square, and you have length. Okay. Also find the dimensional formula by, okay, you can even find the dimensionality formula by this relation. That is C is equals to 1 upon under root of mu naught into epsilon naught. Okay. All clear? Chalo. Good. Great. Now, unit of permittivity of free space. First they asked you permeability, now they ask you permittivity. So this is the formula. Apply it. Okay. Very easy. Now, according to Newton, the viscous force acting between the liquid layers of area A and velocity gradient is this. Again, this is the formula. Focus on the formula. H is the constant. You have to derive H. All right. Okay. I hope everything is clear. Fine. Chalo. This is the solution. You have to derive F. You have to, so from F, you have to basically derive neta. Neta. Okay. So F dimensionality formula, you know already. Del Z and del V, you already know. Okay. Fine. Next question. The frequency of vibration F of mass M suspended from a spring constant K. Okay. Just note this down. Spring constant K is given by a relation of type. Again, they have given you the relation. Just focus on the relation, the focus on the formula, what they have given to you. Okay. Shallow. I hope it's clear. All right. Fine. Going further. So F is equals to CMX into KY. So what is K? Force upon length, correct? This is what you should know. Yeah. And we continue. All right. Next. The dimensional formula of pressure. Okay, what is the dimensional formula of pressure? Pressure is equals to force upon area. Okay, force dimensional formula is MLT minus 2 and area is L square because area is measured in meter square, correct? So MLT minus 2 divided by L2 Now L and L will get cancelled. So ML1, ML minus 1 and T power minus 2. Okay, I hope it's clear. I mean, this is easy, right? It's pretty easy. Correct? Okay, let's move further. Yeah. Dimensionally formula of torque. So you should know the formula of torque. Torque is equals to force into distance. Fine. I hope it's clear. Right? Now, let's move further. Okay. Self-induction. Okay. So for induction, what do you have to know? For induction, it is important that you should know the formula of mutual induction and self-induction, right? So this is electromagnetic induction. So L is equals to, what is the value of L? L is equals to eta into dt by di, right? So eta is W by Q into di by dt. Simple as that. Okay. So this chapter is basically of electromagnetic induction. Fine. I hope it's clear. Go through the EMI chapter. Okay. We study this formula. You have to now derive this formula like this. Okay. For this, eta is equals to W by Q. Okay. Then you have di by dt. Fine. All right. Let's move further. Question 31. Fine. Just a second. Okay. Fine. Yeah. Okay. Now, so angular momentum, this is dimensional formula. Okay. Formula. And you have got this. Okay. Now, the dimensional formula of angular momentum, this is given again. Angular momentum is moment of inertia into angular velocity, right? What is angular momentum? You have studied this in rotation chapter. L into moment of inertia, that is I, into angular velocity, I omega. Correct? Okay. I hope it's clear. So inertia की क्या होती है? This is ml square, and for time it is for omega. Omega is nothing but it is 1 by f. This is 1 by f. Correct? Omega is measured in time. Okay, omega is measured in time. So for that, as omega is measured in time, omega is measured in frequency. So frequency is nothing but 1 upon t. Correct? 1 upon t. This is t minus 1. So mlt minus 1. Correct? I hope it's clear. Okay. Next. If C and R denote capacitance and resistance, the formula of CR. Now just recall a formula where C and R are in a same formula. Just recall. Where do you have this? Okay, where do you have this? You have to recall it. Fine. So CR. So C capacitance is Q upon V. What is R? R comes from Ohm's law. That is V upon I. V will get cancelled. What is charge? Charge is current into time, which is I into T. So I into T divided by I. Okay. Bacho, just notice this. What is capacitance? Q by V. All right. And what is R? It is V by I from Ohm's law. All right. So this V and this V will get cancelled. You have Q upon I. What is charge? Charge is I into T. All right. Charge is I into T. And then you just have T. What is the dimensionality formula of small t? That is capital T. Okay. And rest all M and L will be 0. Okay. Okay. Next. Taking into account of significant figures, what is the value of 9.99 M minus this thing? So go through this. In subtraction of number of decimal places, in result of should be equal to the number of decimal places. Okay. So when you're subtracting, the decimal places should be equal to the highest decimal place. Okay. So you just add 0. Okay. And you just subtract. Fine. So at least 3 number of decimal places. So the answer should hold as 9.98. Fine. Okay. Chalo, it's clear. Now, if energy E, velocity V, and time T are chosen as fundamental quantities, see, we had discussed a question where we had velocity, time, and force, right? Now there's a similar question: energy, velocity, and time. So instead of force, they are just given energy, right? So this is the formula. Okay. I hope you can derive it. Now, Stephen Boltzmann constant. Just recall, where do you have Stephen Boltzmann constant? You have Stephen Boltzmann constant in your uh, heat chapter, right? So heat chapter. So according to Stephen's law, E is equal to sigma into A to the power 4. Okay. Where E is energy dissipated per second. Okay. What is A? A is the surface area. So you have sigma. Sigma is equals to E upon A to the power 4. Okay. What is the quantity of E? It is in watt. Energy watt. What is A? That is m square. What is T? That is K to the power 4. All right. I hope it's clear. Fine. Go next. A screw gauge has a count. Okay. So this is a question for screw gauge. So the least count per screw gauge is this, which is equals to pitch upon number of divisions per circular scale. What they have mentioned is least count, and there are 50 divisions on a circular scale. So we know that least count of screw gauge is 0.11. What is the least count of a screw gauge? This is the formula: pitch upon number of divisions. Okay, which is pitch upon number of divisions. How many divisions? You have 50 divisions. So 50 into 0.01, which is 0.5 mm. All right. Chalo, I hope it's clear. Fine. All right. Chalo, good. Now, in an experiment, the percentage of error occurred in the measure of physical quantities A, B, and C are 1%, 2%, and 3% and 4% respectively. Fine. Then what is the maximum percentage of error? Okay. So they have given that delta x by x into 100 is equals to this. Okay. Just notice the question. 1%, 2%, 3%, and 4%. So just divide by 1 by 2, 1 by 3, and 3. All right. That is 4. Fine. Now go to the next one. The man scale of a vernier calipers. Okay. Vernier caliper. The main scale of a vernier caliper has n divisions per centimeter. Okay. Vernier caliper. Fine. N divisions of a vernier scale coincide with n minus 1 divisions. Then the least count. You should know the formula of least count. So n into VSD is equals to n minus 1 into MSD. So 1 VSD is n minus 1 into n. Least count क्या होता है? 1 MSD minus 1 VSD. That's all. You just need to apply this formula. All right. I hope it's clear. Fine. Chalo. Okay. Now, a student measures the diameter of small steel ball using a screw gauge. Okay. Note one thing, guys. With the least count of this. Okay. This is the least count in centimeters. Now, the main scale reading is 5 mm, and the zero of circular scale division coincide with 25 division. Okay. Check this question. So, diameter of ball, diameter of the ball is MSR plus CSR into least count. CSR into least count. Okay. CSR into least count minus zero error. What is the value of MSR? Given value of MSR is 0.5 centimeters. CSR is 25. 25 into 0.01, and zero error is given to you. Fine. You just need to apply this. All right. Chalo. Next. In the next question, in an experiment of 4 quantities A, B, C, and D, okay, A, B, C, and D are measured with percentage of error. Okay, percentage of error. Just a second. Yeah. Yeah, percentage of error. Fine. 1%, 2%, 3%, and 4% respectively. So the quantity P is scaled as follows. P is equals to this, then the error in P. Now understand one thing. We have the formula of P as A cube B square C by D, C into D. Fine. They said me that delta P by P is basically 3 into delta A by A. Okay. This is 2%, this is 3%, and this is 4%. Fine. A, comma B, comma C, comma D. So this is what you'll write. So 3 into 1% plus 2 into 2% plus 3% plus 4%. Okay, which is 14%. All right. I hope it's clear. Fine. Chalo. Just a second. Yeah. Now, if the error in the measurement of radius of a sphere is 2%, then the error in the determination of volume, see, radius of a sphere, then what is the volume? Okay. Now, delta R by R into 100 is 2%. Okay. Volume of sphere क्या होता है? Volume of sphere is 4 by 3 into pi R cube, right? You just replace the value of delta R by R and delta V by V over here, which will be plus minus 3 into delta R by R. Correct? Right? Okay. So this will be 6%. One trick which I will give over here is that if you don't understand anything, let's say in an exam, if you have forgotten these kind of things, what you take the base value as 100. Okay. You take the base value as 100 and then you proceed. Take everything as 100. Let's say that it is 2% error. That means original value has become 98. Fine. Or it will be 102. It will be said by you that it is 2% more or 2% less. All right. So this is one trick which I will apply. All right. Now, moving further. Let's go to the next question. Yeah. So this question is upon density of the cube, right? So density of the cube is measured by measuring its mass and length of the sides. If the maximum error in the measurement of mass and length are 4% and 3% respectively. Okay. The maximum error in the measurement of density. What will be the maximum error in density? So you have mass and volume. Density is equal to mass by volume, which is m upon L cube. So del L by del is m upon L cube into 3 into del L by L. Because 3 into del L by L, why they have told that mass and length are 4% and 3% respectively. So this is what the formula is. Okay. 3 into del L by L, and you have delta M by M, which will be 4 into delta M by M. Okay. Fine. Okay. So I hope we are clear until here. Let's move to the next question. The percentage error in the measurement of mass and speed are 2% and 3% respectively. The error in kinetic energy. Again, kinetic energy का formula क्या होता है? Percentage of error is m. Kinetic energy is half mv square. You apply the same thing in half mv square. That's all. Delta k by k is equals to delta m by m into 2 into delta v by v. You basically need to calculate the value of delta m by m and delta v by v. That's all. Okay. I hope it's clear. Vernier caliper question. Okay, so n divisions are coinciding with n minus 1 divisions in the main scale. Okay, the least count. So 1 MSD is equals to n minus 1 by n into MSD, right? Correct? Correct. Okay. So 1 by n into MSD is equals to this. Okay. All right. A certain body of this weight, okay, this is the weight, has measured with a volume this. Fine. The possible error in the measurement of mass and volume are given by 0.1. Okay. Then the maximum error in the density. What will be the maximum error in the density? So density. So density का formula क्या होता है? Density is mass by volume. So delta D by D is equals to delta M by M plus delta V by V. That's all. You just need to add that thing. Fine. Okay. In a particular system, a unit of length, mass, and time are chosen. Okay. what will be the unit of force? Simple. We know that force equals to mass into acceleration. So mass into length into time to the power minus 2. Correct? A simple force equal to mass into acceleration was given, right? See, length, mass, and time are given. What is force? Force is equals to mass into acceleration. Acceleration is velocity by time. Acceleration. So length into t to the power minus 2. Correct? All right. Now let's move further. Again, they have given you an equation. All right. They have given you an equation over here. You have to play with this equation over here. Fine. X equal to AT plus BT square, where X is the distance, B is the while T. Okay. So understand. X is distance, T is time. The principle of homogeneity. You can add same quantities if the dimensions are same. All right. So L is equals to B into time square, which is B is equals to L upon T to the power T plus 2. Correct? I hope it's clear. Fine. One thing is principle of homogeneity. Then you have Vernier caliper. Then you have error measuring. These two are same things. Then you have your dimensionality formula calculation. These 4 to 5 things are important in this chapter. Okay. Dimension of stress. Stress is equals to force upon area. Correct? Same as pressure. Now, a physical quantity of dimension can be formed out of C, G, and this thing, where C is velocity of light, G is universal constant. Okay. So derive from principle of homogeneity. Keep everything on X, Y, and Z terms. Okay. True. That's correct. Okay. Okay. I hope everything is clear until here. Now, if energy E, velocity V are chosen as fundamental quantities, again, this is the same repetitive question. Ye pichla question humne, I think we have done it 5 to 10 questions before, right? Same explanation is given. Just make sure you do this thing, okay? Energy, velocity, and time. Surface tension. This time they have given surface tension. Last time they had given, I think, acceleration, right? Surface tension and acceleration. All right. So these are 51 questions which we basically have done. This is the solution provided over here. Okay. So surface tension is given by force into length. So force dimensional quantity is mlt minus 2 and upon L. Then you have energy is equals to force into displacement. You calculate that. Surface tension is expressed as E, V, and T, A, B, and C. So now you basically what you want to do is surface tension, you have to know the dimensionality formula, which is given over here, is equals to energy into velocity into time, A, B, and C. From that, you need to calculate the value of A, B, and C. Okay. Okay. So length, mass, and time are arbitrarily chosen as fundamental quantities. They cannot be derived further. Okay. Please note of this thing. All right. So I hope this point is clear. Okay. So with this, I conclude the chapter of chapter revision of units and measurements. So guys, this is very easy chapter. You just need to remember the formula of each and every chapter, what you have studied in your physics, and you need to learn the basic rules of units and dimensions. Nothing else is there in this chapter, which you have to remember. Okay. So with this, I conclude the lecture, and we will be meeting in the next lecture with the next chapter. Okay. Till then, keep practicing and take care of yourselves. Okay. Thank you.